before the introduction, I have one question about this research, which is how to determine the strength properties of concrete that replace with sustainable material. My first introduction is concrete is one of the most essential building materials that reduce natural resources. Point 2, there are few of sustainable material that can be replaced the uses of natural resources such as coal, ash, rice husk, animal shell and others. This is because when people still use the natural resources as a main component on concrete, it will make our environment produce a pollution such as air pollution and water pollution. And this is also can lead to problems that associated with sustainable development. Point 3. Eggshell is known as waste material or byproduct from hatcheries and food industries. This is because eggshell waste also can be used as fertilizer, animal feed ingredients and other such uses. Other than that, mostly eggshell waste is thrown away in landfills without having undergoing pre-treatment, and due to the connected membrane, eggshell trash in landfills attracts vermin and causes issue with human health and the environment. Point 4 of this introduction, few researchers found that eggshell are a suitable material to use in civil engineering. This is because it can be a stabilizing substance for improving soil qualities and suitability as a subgrade material for road construction. Eggshell, also known as calcium rice material and similar with limestone in chemical composition. In this experiment, eggshell powder will be tested its possibilities in concrete and the performance on how the eggshell powder concretes in terms of strength properties. For methodology part, it starts with broken eggshell was collected from local sources, and shells also were cleaned with regular water and air dried for about 5 days at temperatures ranging from 25 to 30 degrees. Secondly, shells then hand crushed, grinded and sieved through 90 nm. The material that passed through a 90 nm sieve was used to replace the cement, while the stuff that was left behind was discarded. Next, crushed blue granite as coarse aggregate and well-graded river sand as fine aggregate. Fourthly, coarse aggregate was placed into the mixer drum, and portion of water quantity required was poured into the drum. Lastly, cement and eggshell powder were generally placed into the drum and sand was spread over the powder and start mixing. The percentage of eggshell powder that replace cement in this concrete are about 15%. The remaining mixed design water quantity was added into the mixer drum during mixing process to ensure full mixing of the ingredients. After that, the specimens were prepared and left for 24 hours before being demolded and put in normal water to cure till the test age. The performance of strength properties in concrete can be seen in a few tests. So this is the table of mixed proportion of concrete. For concrete name, M1 is stand for control concrete, M2 and M3 and M4 is stand for eggshell powder replace concrete. So in M1 there is no eggshell powder contained. So this is all the quantity that needed in concrete ingredients. Basically, this is the table for compressive strength, which is the first test to determine strength properties of concrete. A compression testing equipment with a capacity of 2000 kN was used to assess compressive strength. The test was carried out on 150 mm cube specimens for a period of 1 day, 7 days and 28 days. Compressive strength test can be concluded that compressive strength was higher than control concrete for 5% eggshell powder replacement at 7 days and 28 days. Of curing ages, eggshell powder replacements that greater than 10 had lower strength than control concrete. So this is what can we conclude from the table of compressive strength. Next, this is the result of split tensile strength. For this experiment, 100 times 200 mm cylinders were employed. On the top and bottom of the test specimens, two pieces of 3 mm thick and approximately 25 mm wide plywood strips were put between the two platens. The split tensile strength test was done on the same machine as the compressive strength test. This table that we can conclude that split tensile strength of actual powder concrete were comparable with control concrete up to 10% actual powder replacement. However, concrete with 15% actual powder had lower split tensile strength than control concrete. Next test is water absorption. So this is the table of result from the water absorption test. Water absorption is to comprehend the concrete's relative porosity permeable blank space. Two 150 mm cubes were used to conduct absorption and permeability voids testing. Saturated surface dry specimen were stored in a 105 degrees Celsius hot air oven until they reached a consistent wake. After removing the item from oven, it was allowed to cool to the room temperature. These specimens were then totally submerged in water and their weight gain was monitored until they reached a stable weight. The concrete quality was assessed using absorption at 30 minutes and final absorption, which is when the difference between two consecutive wakes is almost minimal. All of the concrete's final absorption was found after 72 hours. That's a final time for the water absorption test. From this table, we can conclude that absorption characteristics shows that the initial 30 minutes absorption values for all the concretes were lower than limits commonly associated with good quality concrete. The maximum absorption observed was 1.87% for 50% actual powder. The absorption decreased with decrease in permeable voids. So basically, this is the last test to determine strength properties of the concrete, which is sorptivity test. So this is the table of the result after sorptivity test conduct. The sorption test was performed on the concrete to determine the rate of moisture migration into the pores of the concrete. To monitor moisture migration, 150 times 150 mm cubes were marked at 10 mm on all four sides. The specimen was allowed to cool to room temperature as indicated in the water absorption section. The cubes were placed in the water after cooling process, ensuring that only the bottom surface of the specimen came into touch with the water. The weight gain of the specimens at regular interval was used to measure the moisture rise in the cubes. The weight gain of the specimen per unit area of the concrete surface and the square root of the time for the suction periods were then used to compute the concrete sorption. From the table, we can conclude that sorptivity of the concrete was comparable with control concrete up to 10% actual powder replacement. However, sorptivity of 15% actual powder concrete was higher than control concrete. The maximum sorptivity was for eggshell powder replaced concrete with 0.17 mm per second, the power of 0.5. Sorptivity decreased with strength and increased with water absorption. That's all that we can conclude from the table of sorptivity tests. The part of discussion that we can discuss about this experiment that the chemical makeup of eggshell powder is extremely similar to that of limestone. This is as stated in earlier because eggshell powder and limestone can be tested in the same situation of replaced concretes in strength property. Point 2. Eggshell powder in cement replacement also comes out with different results of strength properties. This can be seen that eggshell powder also can come out with high or low strength of concrete after being tested. According to the percentage of eggshell powder that being added into the mixture of concrete, it is also depending on the age of the disc. Point 3. There are few of main factors that play the important role to control transport properties of concrete, which are volume of pasted matrix, the pore structure of the bulk matrix, and the interfacial zone around the aggregate particles. Point 4. Performance of concrete depends on the particle size of eggshell powder. It can improve the performance of concrete if the particle size of fine aggregates like eggshell powder becomes smaller to ensure the faster interaction with the other components of concrete as reducing a metal size, increasing its reactivity. The last point of discussion, which is the performance of eggshell powder in terms of strength qualities, was extensively investigated, which are compressive strength, split tensile strength, water absorption, and sorption. All of these tests have its own function and purposes towards concrete according to the curing disk.
Assalamualaikum. Hi everyone, I am Nur Shazuna binti Kamara Zaman from class J4 EC11041. So today I will present to you about a project ECS246, which is Civil Engineering Materials. In this project, students are required to do a research about future sustainable concrete or bricks. As for me, I choose RHA which is rice hash as the material used in sustainable concrete. So for the article, I choose the article titled Use of Rice Hash Ash, which also called as RHA, as the cementitious material in the concrete. This article was conducted by 6 researchers. They are from the Department of Civil Engineering, Mehran University of Engineering and Technology at Jamshara, Pakistan. Firstly, I will explain to you about the introduction. In this article, they found out on the use of rice hash ash, RHA, as a partial substitute for cement in concrete to reduce its cost and alternative processing method using agricultural industrial waste. The objective of this research is to determine the fresh and hardened concrete properties using RHA at 0%, 5%, 10%, 15% and 20% by weight. In this era of globalization, the use of concrete is going to increase the growth for demand for its ingredient resources, which are cement, sand and gravel. The making of the ingredients in the concrete, which is cement, can produce pollution. There is a fact said that 1 ton of carbon dioxide will produce 1 ton of cement, while 1.6 ton of natural resources will also produce 1 ton of cement. It shows that using natural resources is better than manufacturing cement produces carbon dioxide. It can can reduce the cause, waste and carbon dioxide emission to the air surrounding that can affect the human respiratory system. So, having RHA as a replacement for cement can save the world from pollution. Besides, RHA is an agricultural waste that is unwanted, which is mostly air burnt or being dumped. To avoid the wasting, the RHA is used in the making of concrete. RHA is a highly pozzolanic material that can be used as additional material in concrete, decreasing the environmental problem. It also has a silica content that can be utilized as partial cement replacement material. So in this experiment, RHA was blended with the concrete by 20% of the way. Secondly, I will explain about the method used in this research. The materials in this experiment, the first one is cement, second one is fine aggregate, the third one is coarse aggregate, the fourth one is rust hash ash, which is RHA, and the fifth one is the water. The tests have been done by having a total of 90 concrete samples, which are 45 cube sample and 45 cylinder sample was prepared. Next, the several train mix are competed using variable cement or binder, coarse aggregate, fine aggregate and water to get the optimum mix. While getting the desirable mix, RHA was used as cement substituent material to determine the characteristic strength of concrete specimen, and ultimately, these concrete specimens were tested on UTM while obeying the British Standard BS code. In this study, the concrete cube were cast for compressive strength and the cylinder were cast for splitting tensile strength. These three concrete specimens were cast for each proportion, and finally an average value of the three specimens was taken as the final result. Based on this article, the work completed in the concrete laboratory of the Department of Civil Engineering, College of Science and Technology. The third one is I will describe about the result and the discussion of this research. The finding is classified into three tests, which are Test A, Test B and Test C. So the data was tabulated in a graph. Firstly, they have done an experiment to know the fresh concrete workability. A test of the flow of fresh concrete was conducted by slump cone. The dimension of the cone is 10 cm top diameter, 20 cm bottom diameter and 30 cm height. Beside me, the graph shows that the maximum flow of concrete was at 65 mm while using 0% RHA as cement substituent material in the concrete, and the minimum value of the workability was at 25 mm at 20% RHA by weight. It was concluded that the flow of fresh concrete decreases with an increase in the amount of RHA in the concrete. The experimental results are shown in figure 1. Next, the B test, which is the compressive strength test, was conducted on cube with volume 100 mm times 100 mm times 100 mm by using a different RHA percentage. 3 specimens were cast for each proportion, and ultimately an average of the value of this concrete specimen was taken as the final result. The compressive strength was maximum at 10% of RHA used as cement substitute material in the concrete, and the minimum at the 20% of RHA at 7 days, 14 days and 28 days. As you can see, the results are shown in figure 2. Thirdly, the C test of splitting tensile strength tests were conducted on cylinder with 200 mm times 100 mm of various RHA percentage with were cut at 7, 14 and 28 days. 3 concrete samples were cast for each proportion, and average was taken as the final result. The maximum splitting tensile strength of the concrete was noted at 10% RHA specimen, and the minimum splitting tensile strength of the concrete was recorded at 20%. The cylinder were tested on UTM. The experimental work Results are shown in figure 3. So what we can conclude by having 3 experiments is the flow of fresh concrete decreases with an increase in the amount of RHA in the concrete. For the first experiment, the flow of fresh concrete was noted maximum while using 0% RHA as cement substituent material in the concrete. The minimum value of the workability was recorded at 20% RHA. In the second experiment is the compressive strength test, was the maximum at 10% RHA concrete and the minimum at 20% RHA concrete at 7, 14 and 28 days. And what we can conclude for the last test C is the maximum splitting tensile strength of concrete was noted at 10% RHA concrete and the minimum splitting tensile strength was recorded at the 20% RHA concrete at 7, 14 and 28 days. From the article that I have been described, it shows that RHA is suitable as replacement of cement for the future sustainable concrete. It also shows that the RHA can reduce the cost, waste and pollution in this concrete making.
Hi, my name is Nur Ilya Umaira binti Abdullah Zawawi and I'm from J4 EC1104A1. So today I want to present to you about my research for future sustainable concrete that have potential in civil engineering. This research are based on the studies that carried out by this researcher. So the sustainable product that used in this research are coal bottom ash. It was used as a replacement for fine aggregate in concrete. What is coal and how does the coal ash bottom is produced? Okay, coal is the main source for electricity and heat. The coal was burned through combustion process at the thermal power plants. So through the combustion process, the burnt coal will produce smoke which goes into the air, which is also known as a fly ash. The bottom ash that comes from the burning coal, which is generated at the thermal power plants. The main problem is the production of coal is keep increasing every year and due to the high demand of the electricity. The production of coal is increasing, so the ash that comes from the burning coal will increase and it will unused and sent to the landfills for disposal. To solve the problems, there is a necessity to use coal bottom ash for sustainability. Concrete is the crucial material for the construction industry that is for construct the high-rise building and other infrastructure. Thus, it is important to observe the properties of the concrete. Concrete was produced by mixture of cement, fine aggregate, coarse aggregate, and water. So they have their own properties, which is moderately high compressive strength but lower in tensile strength. Adding the other materials in the mixture of concrete, it maybe can change the properties of the concrete. So this is become my main objective, which is to observe the effect on the concrete properties by using a coal bottom ash as a partial replacement of fine aggregate. Next, the methodology that using by this researcher is by having a 3 tests, which is Slump Test, Compacting Factor, and Compressive Strength. Slump Test is the most common test that for determine the workability of the fresh concrete. It can be performed in the laboratory or at the construction site directly. However, it is not suitable for very dry or very wet concrete. The result that can obtain from this test is a slump value, which is indicates as the workability of the fresh concrete. The conclusion: the higher value of the slump, thus it means the workability of the fresh concrete is higher. However, if the slump value is too low, it also not a good one because it can shake easily. Next, the test that used in this research is compacting factor test. Compacting factor test, compared to the slump test, it is to determine the degree of the workability of the fresh concrete. It are usually used in the laboratory, but it also can be used at the construction site directly. However, it is very rare to use at the site work because it needs a large device. The advantage of this test, it is more precise and sensitive than slump test, and it is usually used for the fresh concrete that have very low workability. And the last test that was used in these studies is compressive strength. Compressive strength can be defined as the capacity of the concrete stand with the load that push towards them before failure. This test is very important out of many tests that apply on the concrete because it gives the idea about the characteristic for the concrete. This compressive strength was measured by breaking the concrete specimens by using a compression testing machine. In these studies, the compressive strength will be measured after their curing time at 7, 21 and 28 days. It is because concrete will regain their maximum strength at 28 days. In order to determine how much the capacity of the structure or this bottom edge concrete can resist under compression, this test will be able to know the ability of the material to resist failure in the form of cracks or fissure. However, for my opinion, this test was not good because since some of the testing equipments are not available for using at the field. Next, the result that obtained in these studies for slump test, the slump value, as we can see, the slump value become lower. Thus, it means for this bottom edge concrete has a low workability. In this test, this value was from 50 mm to 90 mm, which is a type of medium workability. It will be easier to mix, place, and compacted without any segregations. Since this concrete have medium workability, thus it is typically used for normal reinforced concrete placed with vibration. As for compaction factor result, the range of compaction factor is values from 0.65 to 0.75. Thus, the standard of the workability for this bottom edge concrete is very low. Next, for the compressive strength test, the maximum strength that obtained in these studies is 80.56 Newton millimeter square, 15.44 Newton millimeter square, and 10.69 Newton millimeter square, which is at 28, 21 and 7 days respectively. At that time, it was the least of percentage of the bottom edge was used as the replacement in the concrete. For the discussion, in this laboratory, some percentage of cold bottom edge was used to replace the fine aggregates. Bottom edge particles are much coarser than the fly ash. It has angular and porous surface texture. Bottom ash contains high carbon content and exhibit high shear strength. Thus, with this characteristic, it makes bottom ash is an ideal material for design construction. Bottom ash is an economic material because it is not only good engineering property but also have a construction benefit. Based on the studies that conducted by this researcher, as for the slump test, the workability of the concrete was determined. The workability of the concrete varies when different percentage of bottom ash are added into the cement. The workability of the bottom ash concrete decreased with the increase of the ash content. Bottom ash was foundly consists of angular and very porous surface texture. Thus, it will be easy to absorb water. Slump can be obtained into three types, which is true slump, shear slump, and collapse slump. In these studies, the types of the slump is a true slump. Moreover, the workability of fresh concrete that contains bottom ash show a lower value due to the higher amount of replacement, which require huge amounts of water, which affected the workability. So it shows that porosity and the irregular shape of the cold bottom ash particles can influence the workability of the mixed concrete. What I can conclude based on the result is the workability is the important physical parameters that should be observed because it will be affect the strength and the durability of the concrete, as well as the appearance of the concrete. It must be measured in order to ensure good quality concrete. For the compacting factor, as I said before, compacting factor is for determine the degree of the workability or compacting factor of the fresh concrete. Compaction factor can be defined as the ratio of the weight of fully or partially compacted concrete to the weight of fully compacted concrete. For the normal range for compacting factor is they should lie between 0.8 to 0.92. However, in these studies, the range of compacting factor is 0.65 to 0.75. It is due to replacement of the fine aggregate with the cold bottom ash. For the last, which is compressive strength test, this test was carried out at their curing time at 7, 21 and 28 days. It shows that early strength of the concrete was at low level due to higher replacement or due to higher percentage of replacement with the effects of the short period of curing time. However, due to the effect of Pozzolani action in bottom ash, the concrete will reach their optimum strength beyond 28 days. In addition, in these studies, it shows that the compressive strength of bottom ash concrete lower than normal concrete specimen at all age. It is because the amount of water that contains in this concrete. Bottom ash concrete has higher water absorption compared to the normal concrete. As a conclusion, what I can conclude for using a cold bottom ash as a replacement of an aggregate, bottom ash is acceptable to be used in the construction. Moreover, it is not only used for fine aggregate but also can use for replacement coarse aggregate and the cement replacement.